There are two lateral loads. One is seismic load and another one is wind load. In addition to seismic load, wind load is also a crucial factor in design and construction of any structure, especially in areas prone to strong winds. So, understanding and accounting for wind load is essential for ensuring the safety and structural integrity of the building. By properly considering the wind forces during the design and construction process, engineers and builders can create structures that are resilient to even the most severe weather conditions. Hey friends, welcome back to Civil Engineering Master. In this video, we are going to discuss the factors which are influencing the wind forces as per IS 875-2015. So without further delay, let's begin now. Let's start with the simple term. Wind load refers to the force exerted by wind on a structure. It is essentially the pressure caused by wind that is applied to a building surface area. The pressure can vary depending on several factors like wind speed, building height, shape, and environmental conditions. Now let's look into the factors influencing the wind speed as per IS 875-2015. Location, terrain category, topography, and importance factor. Figure 1 shows the map of India showing basic wind speed. In this map, we can have the basic wind speed starting from 33 meter per second to 55 meter per second. So from this we can come to know the minimum wind speed is 33 meter per second and the maximum is up to 55 meter per second. So according to the color, we can identify which location is coming under wind speed which is given in this table. And also this is mentioned in Annexure A of IS 875. Let's look into that. We have Annexure A, basic wind speed at 10 meter height for some important cities and towns. In this annexure, we have all the city name and the wind speed, basic wind speed. So if you check this wind speed, the minimum is 33 and the maximum you can find up to 55 here. Okay, the first factor is the K1 factor, that is risk coefficient. So based on the basic wind speed which is given in figure 1 and annexure A, we have to find out this K1 factor. We need to take this K1 factor from table 1. Let's consider the city as Hyderabad. For Hyderabad, this comes under this light blue color. So we'll take the basic wind speed as 44 meter per second. So for 44 meter per second, we have to find out the risk coefficient that is given in this table 1. Class of structure, mean probable design life of structure in years, and K1 factor for the basic wind speed. All general buildings and structures, we have the mean probable design life is 50 years, and for temporary structures we have 5 years. Building and structure presenting a low degree of hazard to life property such as isolated tower, wooded area, farm building. Other than the residential building, we have 25 years, and important buildings such as hospital and communication buildings and power plant structures, we have 100 years. So based on this, we have to find out the K1 factor. We consider general buildings and structures, we can consider 50 years return period, and the basic wind speed we have seen for Hyderabad is 44. For the 44 meter per second basic wind speed, all general building and structures, the risk coefficient comes under 1. K1 factor is 1. So if you take this temporary shed, then you have to consider the value of 0.73, and if your building falls in this third category, you have to consider 0.91, and fourth category means you have to consider 1.07. The locations near the sea experiencing the maximum wind speed of 55 meter per second, whereas the locations which are far from sea, the interior region of India, experiencing the lower wind speed of 33 meter per second. Ground roughness is one of the influencing factor for the design wind speed at a particular location. In flat terrain, wind speed remain uniform or it increases slightly, whereas in rough terrain, the wind speed decreases due to roughness of the ground. The second factor is K2 factor, that is terrain factor. In IS 875, there are 4 terrain categories. Category 1 is the open terrain with few or no obstruction, in which the average height of any object surrounding the structure is less than 1.5 meter. This category mainly represents the open sea coast and flat plains without trees. Second category represents the open terrain with well scattered obstruction. and the height is 1.5 to 10 meter. Third category represents the closely spaced obstructions having the size of building and structure up to 10 meter in height with or without a few isolated tall structures. Category 4 represents numerous high closely spaced obstruction, and the equivalent aerodynamic roughness height for this terrain is 2 meter. So this aerodynamic roughness is different for all the categories. For category 1 it is 0.002 meter, for category 2 it is 0.02 meter, and for category 3 it is 0.2 meter, and for this category 4 it is 2 meter. In table 2 of IS 875 we get the height multiplier value, that is K2, for different terrain categories. We have seen the 4 terrain categories, and for that multiplier values are given as per the height. See here the height starting from 10 to 500, and if your building falls in terrain category 1 you have to find out the height of the building, and then according to that you have to choose the terrain category. For example, if 20 meter is your height and your building falls under terrain category 1, you have to take the multiplier value as 1.12. In the same manner, for other heights and other terrain categories, you can take the K2 factor values. All the building heights will differ. So for intermediate values of height, we have to use the linear interpolation to get the multiplier values. The third wind speed influencing factor is the topography factor. The ground features like hills, valleys, cliffs are also affect the wind speed. You may have observed that the wind speed increases at the top of the hill. And if the ground slope increases, the wind speed also get increases. If the ground slope decreases, the wind speed also get decreases. It is vice versa. The basic wind speed in hills, valleys, cliffs, escarpment or ridges are not same as per the basic wind speed which is given in the wind speed map of India in IS 875, as it varies with the local topography. So as per the slope, the wind speed will vary for the hills, valleys, cliffs, escarpment or ridges. If the upwind slope is 3 degree and below that, the value of K3 is equal to 1, and the value of K3 is in the range of 1 to 1.36 for slope more than 3 degrees. Evaluating the value of K3 more than 1 is given in Annexure C. There is some formulas which is given in Annexure C if the value of K3 is more than 1. In Annexure C, the formula is given to calculate K3. K3 is equal to 1 plus C S0. Here, according to the slope, we have to find out the values. The factor S0 should be determined from figure 14 and 15. We have figure 13A, that is for general notations. Here the wind slope, downwind slope is given theta, and the distance from the crest. 13B is for hill and ridge, 13C is for cliff and escarpment. And here figure 14 and this one is figure 15. So from these figures we have to find out the S0 values, and finally we have to find out the K3 factor. The last wind influencing factor is the importance factor K4. The wind speed during cyclones or storm is significantly more when compared to the basic wind speed. In fact, studies shows that the wind speed during storm can reach up to 70 meter per second, that is much higher than the basic wind speed 55 meter per second which is given in IS 875. In India, East Coast region is most vulnerable to cyclones, and in West Coast, Gujarat is more vulnerable to cyclones. So to ensure the better safety of structures in that region in and around 60 kilometer width at that coast, the following values of K4 can be considered. Emergency services such as cyclone shelter, hospital, schools and communication towers 1.3, and for industrial structure it is 1.15. For all other structure it is 1. So these values has to be taken as importance factor values for the cyclonic regions. So friends, we have discussed all the wind speed influencing factors. I hope you like this video. If you really like the content, hit the like button, also share it with your friends, and your comments are always welcome. Don't forget to subscribe the channel for more videos. Thank you for watching.